Hello everyone, I hope you all are doing great. In today's video, I'll come up with the next topic of basic chemistry concept, that is isotopes. And before directly delve into this topic, I'll think we have to discuss atomic mass first. Firstly, in the last video, I have been describing that what is atom, what is the molecular atomic mass or something. So in this topic, I was trying to cover up the isotopic mass and why we mention atomic mass in the periodic table. If you, after listening the past video, if you have been try to observe the periodic table, you will find out that atomic mass is not like a whole number as your atomic number, right? तो जब भी हाइड्रोजन को आप चेक करते हो you will be able to find that hydrogen has one atomic number, helium has two atomic number, and in the same way periodic table will be arranged, right? But when you look at above the atomic number, you find that the atomic mass number, as I described in the atomic symbol, you have been find the above portion dedicated to the atomic mass, and there you have been find out that that is not a whole number, because as we mentioned that proton has a whole number, neutron has whole number, electron has whole number, then why should we won't be able to get that whole number atomic mass, right? They have been mentioned some kind of fractional digit over there. So before directly create any kind of mess here, I'll describe the definition first. What is atomic mass? Atomic mass is basically the average mass of all the naturally occurring isotopes, right? तो अभी question automatically arise हुआ, what are isotopes then? Okay. The atomic mass has a unit U or AMU. In some books, you are able to find out the atomic mass written with U, and another is atomic mass unit, basically, right? What is the atomic mass? Unit is 1/12 mass of a carbon 12 atom. क्योंकि जो carbon 12 atom है, उसका जो atomic mass है, वो exactly number हमारे पास से 6 is exactly double 12. तो और कार्बन क्या है कि हमारे जो पीरियोडिक टेबल में है दैट विल बी द मोस्ट स्टेबल मॉलिक्यूल, और जिसकी मैक्सिमम कैटिनेशन प्रॉपर्टी है. ड्यू टू दिस वी आर एबल टू डिजाइन आवर ऑर्गेनिक केमिस्ट्री इन अ वेरी वास्ट वे. सो इसीलिए ये एक बेसिक रेफरेंस यूनिट है. जो कार्बन का जो स्ट्रक्चर है, जो प्रॉपर्टीज हैं, वो टाइम के साथ या चेंज नहीं होती, राइट? तो उस पर टेम्परेचर का लीस्ट इफेक्ट है. दैट्स व्हाई वी कंसिडर इट एज अ रेफरेंस मॉलिक्यूल. जब कभी भी वेन एवर वी आर एबल टू डिजाइन सम काइंड ऑफ unit system, we are considering some kind of reference so that in every region it will be the same one. So it is usually not a whole number because it is an average. As I already mentioned that when you look at the periodic table, you are able to find out that that is an average number. Okay. So the next thing come into our mind are what are isotopes exactly is. The isotopes are atoms of same element that have a same number of protons and different number of neutrons. Before, when we are able to design our periodic table, before directly designing it, we are following the several kind of periodic table beforehand. As we discussed about the modern table, before that there is a Mendeleev table, Newland's octave table. So these kind of tables mentioned as the existence of isotopes beforehand, because it says that hydrogen is not exist in the 1H1 form. It exists in the 1H2 and a 1H3 as well. So these are basically isotopes where atomic number is same but mass number is different. So keep in mind that whenever we are talking about the atomic mass, we always consider the isotopes, right? They have same atomic number, same number of protons, but different number of neutrons. Clear? So another thing is they have a same atomic number, as I mentioned, different mass number. So it's basically to break down that definition into some clear specific statements that same atomic number होएगा or different mass number होएगा. Then we only call it as a isotope. Okay. they have similar chemical properties but different physical properties like mass उनका फर्क होने की वजह से उनका physical property क्या है, it is little bit different. Clear? So next is the how we are able to calculate the atomic mass then, right? तो अभी atomic mass क्या हो गया, isotopic mass जैसे जैसे हम लोग it's kind of cabbage, जैसे जैसे आप लोग deep down जाते रहोगे we are unraveling the layers of chemistry so that कि हमारा concept क्या होता रहे, rigid होता रहे by the time, right? अभी आइसोटॉपिक मास जो उस पर्टिकुलर आइसोटोप को आप कंसीडर करोगे विच आई बी एबल टू हेल्प यू विद द न्यूमेरिकल सो दैट यू गेट द hold over this formula. Isotopic mass into the fractional abundance divided by 100, right? So isotopic mass they have been given you. Let's consider the numerical side by side so that you can able to understand what I'm trying to say. क्लोरीन हैज टू मेन आइसोटॉप्स. तो क्लोरीन के बेसिकली दो आइसोटॉप्स हैं. वी नो दैट क्लोरीन हैज एटॉमिक नंबर 17. इट्स एग्जैक्टली हम सोचते हैं कि डबल होना चाहिए बट इट्स हैज मोर कि एक ज़्यादा है 35 और 37. क्लियर? तो बेसिकली हम कंसिडर करते हैं जब आइसोटॉप में आप आ जाते हो तो जो उस पर एग्जैक्टली मास नंबर में मेंशन हुआ है दैट विल बी द एटॉमिक मास फॉर दैट आइसोटॉप. लेकिन जब हम पीरियोडिक टेबल में एज वी आर नॉट मेंशनिंग द आइसोटॉप्स दैट्स व्हाई वी आर मेंशनिंग द एवरेज मास ओवर देयर फॉर द वन पर्टिकुलर एटम. तो पहले जब हमारे पास मेंडलीव का पीरियोडिक टेबल था तो उस टाइम पे वी आर मेंशनिंग द आइसोटॉप्स इन दैट सेम रीजन बट लेटर ऑन दैट पीरियोडिक टेबल बिकम क्वाइट कॉम्प्लेक्स. सो उसको सिंप्लीफाई करने के लिए हमने मॉडर्न एटॉमिक टेबल कंसिडर करा so that we are able to mention only the one atomic number over there and average mass over there. तो उस वे में हमने अपना periodic table modify किया है जो हम मॉडर्न अभी अब स्टडी करते हैं. तो उसमें अभी डायरेक्टली हमें क्या पता चला, एक की तो आपको जैसा आइसोटॉप मिला यू आर एबल टू फाइंड आउट दैट मास ऑफ दैट पर्टिकुलर आइसोटॉप. तो उसका क्लोरीन 35 विल बी 35 एटॉमिक मास यूनिट, 37 का 37 एटॉमिक मास यूनिट. Now question arises, what are the isotopic abundance? Isotopic abundance is the basically probability of finding that particular isotope in that bucket. For example, to simplify it in a very basic manner, that you are considering a bag full of balls of different colors, that is red, blue, and green, right? And all of a sudden, I came to the class and I said that pick one yellow ball from that bag, but you are not supposed to look at inside the bag. So what you can do is whatever the trial you have been given to you, but you are not able to find out the yellow ball inside it, right? Because I already create the bag with the red, green, and blue balls. So in the same way, if we are performing any kind of practical, we are able to find out that when we able to detect the particular atom, how much it will be probability of that particular atom to be in that bag, right? So in this way कि अगर हम सिस्टम में स्टडी कर रहे हैं क्लोरीन को तो how much probability or how much will be the probability to find that particular isotope. तो 75% चांस हमारे पास रहेगा कि हमारे अगर हम 100 एटम कंसिडर कर रहे हैं तो एज वी नो दैट कि हमारे जो एटम्स है दे आर वेरी टाइनी पार्टिकल्स. सो we are not able to quantify that in that sense, but still in order to explain you that what is the isotopic abundance exactly is that when we if we consider the 100 molecules of chlorine atom whose average mass is 35.5 U, how much is the probability that we get the particular isotope we are talking about? Like as chlorine has more tendency, right? तो अगर हमारे 100 atoms का एक bag create करेंगे, we are creating the bag of 100 atoms for the chlorine atom. तो out of 100, 75 will be the maximum probability कि chlorine 35 ही होएगा. तो दैट विल बिकम द आइसोटोपिक अबंडेंस। कि हम नेचर में, हमें अगर हम नेचर को एज अ बैग कंसिडर करें, तो उस नेचर के अंदर क्लोरीन विल बी 75% आइसोटॉपिकली अवेलेबल, राइट। तो अगर आप सिस्टम में स्टडी भी करोगे, तो उसमें से 75 मॉलिक्यूल विल बी योर क्लोरीन 35 एंड द रिमेनिंग 25 विल बी chlorine 37. This will helps us to identify the spectroscopic properties of these isotopes, which this is not a part of discussion now. So let's come to the topic again. That is atomic mass now will be become 35 into 75 divided by 100, as I mentioned you. But अगर आप पहले से ही 75 by 100 को divide कर लोगे, it simplify your calculation only. That's the only thing it happens with. That becomes as 0.75. Okay. तो उसी तरह से what you have to do is sigma they have mentioned is to plus sign. If they have mentioned the pi sign, you have to multiply that. Clear? तो 35 into कितनी abundance है उसकी abundance के साथ multiply कर दो, 37 into 0.5, तो you get some number that is 26.25 and 9.25, and the average become 35.5 U, okay, or AMU. So the atomic mass of chlorine is 35.5 U in your periodic table sheet. When you look at your periodic table, you find that they have mentioned the chlorine 35.5 over there. Clear? जब कभी भी आप calculation करते हो in order to prepare the solution or something, you are considering the average mass, not the isotopic mass. Clear? The next molecule is next atom is carbon. I was pick up those examples which you in numericals you find these molecules again and again, and I want to apply that calculation over these atoms so that whenever you apply doing any kind of numerical, you have short that this is the average mass or these kind of things will be happen in that molecule atom. So, carbon has three natural isotopes, carbon 12, carbon 13, carbon 14. And out of all these three, carbon 14 is a radioactive one. Why I try to mention it that radioactive materials are degraded with the passage of time. तो अगर आप अभी आपको मैं बात करते हुए आपको 2 ग्राम कार्बन 14 का रेडियो एक्टिव बताती हूँ, तो आफ्टर 7 मिनट्स और 10 मिनट्स जो भी आप फ्रैक्शन टाइम फ्रैक्शन कंसिडर करोगे, तो उसका क्वांटिटी क्या हो जाएगा, रिड्यूस हो जाएगा. In order to create the average atomic mass, we need those kind of isotopes only which have with the long passage of time their identity remains same, because we mentioned that their chemical properties will not be changed, right. तो इसीलिए जब हम एवरेज मास कंसिडर करते हैं, वी आर ट्राइंग टू कंसिडर ओनली दोज आइसोटॉप्स विच आर नॉन रेडियोएक्टिव, जो पैसेज के साथ खत्म नहीं हो रहे, दे आर लिटिल बिट स्टेबल, राइट. तो कार्बन 12 एटॉमिक मास, फिर से वही कार्बन 12 का एग्जैक्टली आप 12 यू लिखोगे, उसका 13 यू लिखोगे, और उसकी जो आइसोटॉपिक अबंडेंस है कार्बन 12 की, दैट इज 98.89, अप्रोक्सीमेटली 99 ही होगा, और उसका 1.111 टू बी एग्जैक्ट, क्योंकि जितना आप एग्जैक्ट रहोगे अपनी फ्रैक्शन में उतना आपका एक्यूरेट एटॉमिक मास आएगा. क्लियर? तो ऐसा नहीं है कि अगर हम आपको न्यूमेरिकल में दे हैव मेंशनिंग दैट सिग्निफिकेंट फिगर्स इज द बेसिकली हमारे पास डेसिमल के बाद हम 2 डिजिट कंसिडर करते हैं नॉन जीरो इन ऑर्डर टू एक्सप्लेन दैट मॉलिक्यूल एटम और जो भी आप कंसिडर कर रहे हो, तो ये रूल है. क्लियर? तो हम 2 डिजिट तक कंसिडर करते हैं. तो 1.111 फिर से वही, आप उसके एटॉमिक मास को उसकी आइसोटॉपिक अबंडेंस के साथ मल्टीप्लाई करोगे, बट इन द डेसिमल फॉर्म डिवाइडेड बाय 100 करके. क्लियर? तो 13.03, 0.011 एंड यू गेट सम नंबर, एंड द एवरेज एटॉमिक मास विल बी 12.011 फॉर द कार्बन. तो कार्बन का आपको जब पीरियोडिक टेबल चेक करोगे, दे हैव मेंशन्ड 12.01 ओवर देयर. एटॉमिक मास ऑफ अ हाइड्रोजन, हाइड्रोजन कार्बन हाइड्रोजन और ऑक्सीजन को मिलके हमने पूरा ऑर्गेनिक केमिस्ट्री क्रिएट करा है. दैट्स व्हाई आई कंसीडर दीज एग्जांपल्स. मेन आइसोटॉप इज द हाइड्रोजन प्रोटियम, ड्यूटेरियम एंड ट्रिटियम. बट एज आई मेंशन दैट जो स्टेबल ज्यादा होएगा, वी आर कंसिडरिंग दोज आइसोटॉप्स ओनली. तो मास उसका 1.0078, और जो ड्यूटेरियम का मास है 2.01 4 41U, the isotopic abundance they have given you. And when we apply on the formula, with the formula, we are able to find out that the average atomic mass for the hydrogen is 1.08 or 1.008 atomic mass unit. Okay. Next is the what is the atomic mass of oxygen then? Oxygen is basically existing in the three isotopes, and we are considering all of these ones 16, 17, and 18. Abundance are relatively respectively mentioned that 19.76, 0.04 and 0.20. तो उसी तरह से आइसोटॉपिक abundance को उनके रिस्पेक्टिव एटॉमिक मास से आप मल्टीप्लाई करोगे and you will get the atomic mass. On अभी we are discussing very basic chemistry. तो इसमें जो whenever you have given some kind of numerical portion, they are providing you the exact calculations. Clear? तो वो आपको exact statements देंगे. They don't want you to remember all the stuff. But yes, for me, I always consider that it's better to learn few things in order to reduce your calculation time. Clear? तो आप कार्बन, हाइड्रोजन, ऑक्सीजन का मास, एवरेज मास, जो अगर आपको लगता है एटॉमिक मास, जो आइसोटॉपिक मास है, तो वो एग्जैक्टली हमें याद करने की ज़रूरत नहीं है. बट इन दीज एटॉमिक मास इज एवरेज एटॉमिक मास वी नीड टू लर्न टू सॉल्व द न्यूमेरिकल इन अ फास्ट वे. क्लियर? तो अगर if in case examiner will be providing, that is good. If they are not able to provide you in the numerical in the exam, you are considering the double. तो आप डबल कर देते हो हमेशा. बट इट्स गुड कि आप उसको एग्जैक्टली याद रखो. I think that's all from my side. In this video, let's recall this again. What we discussed, that is, first is the atomic mass, and when we find out that atomic mass is dependent upon the isotopes, then we unravel the concept of isotopes. What are the isotopes? Why we considering them? And what is average atomic mass? And try to apply that average atomic mass with the help of numericals so that we get some kind of understanding and a hold over the concept. Apart from this, I'll suggest you that try to follow some kind of your academic books so that you can able to practice more examples, even more examples, and try to learn those concepts or those numbers which prefer to mention you that you have to learn in a future so that you can not be able to suffer. Like as in the numerical portion, I have mentioned that you have to learn that carbon, hydrogen, or oxygen atomic mass, average atomic mass, so that you can solve maximum number of numericals whenever carbon or hydrogen's involvement is there. Apart from this, I think uh, there are try to follow the playlist from the basics because it will be helps you to understand the concept line by line, because whenever we move in a right steps, I think we are able to understand the concept in a better sense rather than mix and match or kind of thing. That's all from my side related to this video. And thanks for listening, guys. Please try to share it, subscribe it, and try to comment what kind of numericals or what kind of topics you expect that you want me to discuss or create videos upon. This will help me to channelize my energy and direction. That thank you so much for listening me so patiently.